So now we'll discuss what is Six Sigma. So quality improvement through Six Sigma. So we first see the history of Six Sigma, then define Six Sigma, discuss the heroic goal of Six Sigma, the methodology for quality improvement followed by Six Sigma, and the organizational structure, how the organization should be created for implementing Six Sigma, and some success stories. So that is the first presentation. So I got interested in Six Sigma when there was a lot of news reports several years back about Mumbai's Dabbawalas. I don't know whether now it has become old news. So these Dabbawalas, what do? They collect tiffins from home and deliver to offices. So people who go to office for work, so they don't have to carry the tiffin. So the family will make the food and keep in a tiffin, and the dabbawalas will collect the tiffin from home at say 12 o'clock and deliver at the office by 1 o'clock at their lunchtime. So thus family need not make food in a hurry before their leave. And they are handing around 1,75,000 tiffins daily. And it was reported that they make a mistake only perhaps once in 2 months. So a mistake in delivery or a delay in delivery, that is very rare. So they charge just rupees 150 per month. So this level of quality, they said it was, this article came in Forbes magazine, business magazine, and they said it is equivalent to Six Sigma quality. So I heard about this report that a lot of newspapers and all reported that means Dabbawalas have been recognized to have Six Sigma quality. But I was working in quality for so long, I didn't know what is this Six Sigma quality. So then I started to search and find out what is this Six Sigma. So Six Sigma originated at Motorola. It all started with a meeting where Art Sundry, the marketing director, made a statement, our quality stinks. So the reason was that they were losing market share to other Japanese and European companies, and they were having a meeting to discuss what are the reasons. So Bob Calvin, the CEO at the time, decided that they had to improve quality, otherwise they will not be able to sustain in the market. So he started a quality improvement program. And as a part of that program, Bill Smith, who was an engineer there, he came up with this theory of latent defects. So he analyzed the customer complaints from with respect to various products and found that products which had a lot of rework in the factory, they had lot of customer complaints also. So whereas products which did not have much of problems in the factory during production did not have any complaints after reaching the customer also. So he said that even though we are doing rework and rectifying the product, still there are defects hidden in it, which are revealed when it reaches the customer. So the solution is we have to improve our process capability so that the products will not be having any defects at the factory stages. And then if it reaches the customer also, there will not be any complaints. So that came to be known as the theory of reactor defects. So to achieve this, what should be done is to have capable processes. Then defects will not be there in the factory or after reaching the customer. So they were developing a new product, a pager, so which is a device where we call a number and he will get a message that he has to call back. So that system was there earlier. Now we don't have that. So that time network coverage was not very good. So they decided to develop a pager which had all the features of the good pagers at that time. So they stole the ideas from everybody. That's why it was called the bandit page. And then the US government instituted what is called the Malcolm Partridge National Quality Award. So where they had to present what improvement they have achieved and share the secrets of that improvement with everybody. So they applied for that, and the first Malcolm Partridge National Quality Award was received by Motorola. So that's how Six Sigma originated. People are not willing to discuss the real situation. Many times, what they give for publicity is something different. Okay, then Allied Signal was another company which was close to bankruptcy, and he also heard about the success story of Malcolm Bart, this Motorola, and then they also implemented Six Sigma. Allied Signal was taken over by Honeywell, so now this company, as of on its own, it's not there. So from close to being closed down, they turned over and started making excellent profits, and they were soon taken over by Honeywell. And the company which made Six Sigma a household name was General Electric. So they started implementing in 1995, and the key person was Jack Welch. So he writes in his, he does not write, somebody else writes on behalf of him. Straight from the Gut is the book which describes his philosophy and how they went for Six Sigma. So actually, Jack Welch, the other people from Motorola and Allied Signal, they were in a golf club. And from there, they discussed, and Jack Welch said, we will also implement Six Sigma. And the other said, no, you are too big a company, you are a very wide product range, so it is not suitable for you. Whereas other two were electronics industry, and it was the products were very limited, only one mobile phone and this. Whereas we had a wide variety of products, from electric bulbs to MRI scanners and all, such huge products, costly products was also there. But then a lot of service industry also. They were also in some finance, so giving loans and all. So wide variety, so it's not suitable for you, was it? No, it can be, we will implement it, and they had a bet whether he can implement it or not. And that's how we started implementing it on a large scale. So throughout all his organizations, we implemented Six Sigma. That was the major difference between GE's approach and other companies' approach. Motorola, though they originated, they did not go on a wide scale. So they thought, okay, it's a very technical methodology, so not suited for other places. And it's not necessary to have that good quality. That is what generally people say. Why do we need Six Sigma quality in all our products? Okay, so that was the philosophy. Anyway, Jack Welch implemented it in General Electric, and that's how it became popular in India also. So GE, they used to get castings from. Okay, that's how I also got to know about it earlier. So they were getting castings from Coimbatore. So one company, the castings were produced by. They were getting components from Coimbatore, and the components for the castings for that were being produced by PK Steel at Cherunur. So PK Steel, so GE said that all their suppliers also should have these Six Sigma metrics and all. And so they asked their supplier, who was that was Craftsman Automation in Coimbatore, to give the data. Then Craftsman in turn asked PK Steel to give the data. So the strength of the material and all the castings, they wanted to give the data. So they were afraid whether if you simply give the data, it may get rejected or anything. So they came to us for analyzing what is the process capability. So they have to show process capability. So how do we analyze it? All that their doubts, they came to us. So that's how that's what even in India also it became popular because of GE. They were getting many products from India, and of course Wipro was there, who was associated with them, and Wipro also implemented Six Sigma in their facilities, and that's how it became popular in India also. So Wipro people got trained at GE, and then they started doing consultancy also. They were offering courses on Six Sigma. Okay, so this is the book by the original people, Michael Harvey and Richard Kroger. They were employees at Motorola. So when Allied Signal implemented Six Sigma, they went and helped Allied Signal. And later, when GE started Six Sigma on a large scale, then they left Motorola and started their own consultancy. So finally, okay, they had a huge business in 1998. I don't know what is the situation now, but Michael Harvey has retired. He is now, very soon, he retired and started a ranch in Texas. Okay, so this is the book which gives the basics of Six Sigma, the first book on Six Sigma. So, the Breakthrough Management Strategy, Revolutionizing the World's Top Corporations, Michael Harvey, George Kroger. Okay, so that is the history of Six Sigma. So, that's where it all started. So, how do we define Six Sigma? So, again, there is no unique definition. So, there is no official definition. That is one of the problems. So, everybody has their own definition. A lot of people have written books, a lot of books are there, and we get various definitions. So, this is the definition given by Lucas in an article published in Quality Progress in 2005. He defines Six Sigma as a methodology for disciplined quality improvement. So this article I have uploaded in the Edu server, so you can see this article. So in that he says, so this is a methodology, a set of methods how to improve quality in a very disciplined fashion, structured fashion. Then, so Montgomery also wrote an article about Six Sigma. That article is also there in Edu server. In that he says, Six Sigma is a discipline. Again, discipline is coming here. Project oriented. So all improvement is by project basis. So we implement several projects. Altogether, they result in a drastic improvement for the organization throughout. So it is project oriented. When statistically based, so it makes use of statistics. So of course, the sigma comes from statistics. Sigma is standard deviation, measure of the variability. So statistically based approach for reducing variability. So variability is quantified by by sigma, and the measure of that is sigma. So removing defects. So eliminate defects, improve your process, automatically defects will be reduced. So that's the approach in Six Sigma. And eliminating waste from products, processes, and transactions. So eliminating waste. So reduce scrap, rework, processes, improve your process capabilities, and transactions, interactions between two people. So that's a transaction. So by eliminating waste in all these areas, we improve quality. So that is the definition of Six Sigma according to Montgomery. Okay. So Six Sigma, there are numerous other definitions also. Anyway, what are the common points of Six Sigma? So that is, we say the themes of Sigma. What does Six Sigma focus on? So genuine focus on the customer. So Six Sigma focuses on the customer. So we try to understand the customer. So the people usually contrast it with TQM, but nobody says that you should not have genuine focus on the customer. TQM also says you should have focus on the customer. But many times what happens is that it gets diluted. So Six Sigma once again says genuine focus on the customer. Then Six Sigma focuses on data and fact-driven management. So data, it is data-based, management by data. So otherwise management is through hunches. So immediately, okay, somebody says there is a problem, immediately, usually what happens in many companies, so the big boss will decide, okay, let us do this. And then everybody else follow. That is not the approach in Six Sigma. In Six Sigma, so once you hear about a problem, you try to find out the causes and it will not be imposed from the top. The team, the quality improvement team will suggest the solution. So data and fact-driven management. Processes are where the action is. So all the processes, they examine each process one by one, ensure that each process is capable. Then the entire processes sequence will be capable. Proactive management. It is not reaction. So it is not reaction is usually when a customer makes a complaint. Then you start identifying what is the problem and taking action. But instead, before customer complaints, so that's why before at the time of process, when you're manufacturing the product itself, you can check the process capability. So it is proactive. Before it reaches the customer itself, you can identify what will be the quality. So we say it is a proactive system. Boundaryless collaboration. So many places, the biggest problems are always interdepartmental. So how to break down the boundaries? Okay, any question? Okay, so how to break down the boundaries? So that is to one of the important aims of Six Sigma. So Six Sigma, the project teams are always, team members will be from different departments. So in each department, that team member will be responsible to implement the solution in that department. So like that, we break down the boundaries. So boundaryless collaboration. How to achieve that is one of the goals of Six Sigma. So Six Sigma. So what is the meaning of Six Sigma? When we understand, we realize this. It's a drive for perfection. So Six Sigma usually, before Six Sigma became famous, people were acceptable with Three Sigma quality. So generally, Three Sigma plus or minus Three Sigma means 99.73% of the population. So that was enough to achieve a CP of more than 1. That was supposed to be good enough. So why should we go for Six Sigma quality? So the aim is to drive for perfection. Okay, so the logic of multi-sequential steps. So when there are several steps in a process, at each step, if you have only Three Sigma quality, the overall quality will be much lower. But each step, if you have Six Sigma quality, then the overall quality will be Three Sigma. So that is why we aim for perfection. So processes have to be near perfect. But of course, that does not mean that we will not tolerate failure. We have to. When we do anything new, definitely there will be failure. We have to tolerate failure. But that does not mean that we do not strive for perfection. We should always strive for perfection. So these are the 6 themes of Six Sigma. Okay, so these are the concepts which everybody says or they can find in Six Sigma organizations. So now we come to the heroic goal. So what is this Six Sigma? So Six Sigma's goal is perfection. Okay. So near elimination of defects from any process, product, or service. So this is the goal. So there should be no defects. So previously there was a methodology for improvement based on defects that is called the zero defect system. But again, that is criticized. So all these quality people, they always criticize each other. And actually sometimes they will be aiming for the same thing. So that is because okay, a lot of people are businesses. Okay, quality consultancies are there. They help businesses achieve something, and then to maintain the business, they use their own terminology. Okay, so as I said, Ray Fabel's book. So he has trademarked many of the terms used in Six Sigma, which has become a problem for others. So anyway, the statisticians generally do not say zero cannot be zero, so we have to have some process capability. So they say the target of Six Sigma is maximum 3.4 defects per million opportunities. Okay, so this is the goal of Six Sigma. So numerical goal of Six Sigma. So this is non-numerical. So some people don't say this numerical goal, but the numerical goal is 3.4 defects per million opportunities. So how do we get that? So if USL means upper specification limit, LSL stands for lower specification limit with the distance between the two. So for any product, usually the designer will specify specifications, how much is allowed. So the diameter of a shaft should be between lower specification limit to upper specification limit. So if the product dimension is beyond upper specification limit, it is non-conforming. If it is below lower specification limit, it is non-conforming. Ideally, it should be on target, which is USL plus LSL by 2. So what should be this distance compared to the sigma of the process? So sigma is the variability in the process. So according to Six Sigma, USL minus LSL should be equal to plus or minus 6 sigma. That is, the distance between these two should be equal to 12 sigma. So that appears to be a very tall task. So what is plus or minus 6 sigma? So it is very almost double the length given for plus or minus 3 sigma. Is it really necessary? But there is a relaxation. So plus or minus 12 sigma will happen if the process is perfectly centered. But such perfect centering is not possible in practice. So we have to allow some shift in the center. How much shift? So we allow a plus minus 1.5 sigma shift. So it can be plus 1.5 to the right side or plus minus 1.5 to the left side. The mean is shifted from the target. And what will be the defect level? That will be 3.4 defects per million opportunities. Okay, so this is 0.034. Okay, this is 3.4 into 10 raised to minus 6. And if you multiply by 100, that will be 340%. Oh, sorry, other way around. It should be 10 raised to minus 6 into 4 is 34, 340. 0.0034. So it is less than 0.0034%, then it is meeting Six Sigma quality. Okay, we'll discuss in more detail later. Just to understand this, there's a shift allowed and the defect level is 3.4. Remember these numbers. So there are some papers which could just why 1.5 sigma, why not 2 sigma, or why not only 1 sigma. So you can question so many things. And why allow a shift itself? So the idea is that we can avoid inspection. So once you achieve this process capability, so inspection is also a cost. So if you can reduce that inspection, that cost can be saved. So that is the idea of Six Sigma. You eliminate inspection. Once you achieve this process capability, then you can eliminate inspection. So you can save costs. So thus, then you don't have to, because we are allowing, even if the worst it is 2 sigma shift, then also the possibility of a defect is reduced. So that is the aim of Six Sigma. To achieve, once you achieve, your processes are of such high capability, then quality levels will be automatically achieved. So this is the what happens in the situation. So you are allowing 1.5 sigma shift. So here we have 0, this is the target. 1.5 sigma, the mean of the normal distribution shifted. Then you will have, this is the non-conforming area. And that is, so if you are in this area, it is non-conforming. So if you are shifting this side it will be even less, but this side it will be more. So both this plus this is the total area which is non-conforming. So normal distribution. Okay, so just wondering because some of you have already we have used normal distribution. So others are okay. In manufacturing, people are already familiar. What about you? Regina, what is your? You should get your mic and speak if necessary. Can you speak? So you are familiar with this process. I mean, normal distribution. How to find the area from a normal tables? You are familiar? And other people, okay. Ebin and what about Ebin and Vishnu?
No, sir.
Not familiar. Okay. Okay, we'll briefly review later. So, normal distribution. The majority of you are already familiar, that is not a problem. When you use the revised table, so then it doesn't matter. Okay, so this is Six Sigma process, a Six Sigma process. So in this, if it is shifted by maximum 1.5 sigma, and this from the target, it is plus or minus 6 sigma this side, then the maximum area here will be 3.4 per million. Okay, 3.4 into 10 raised to minus 6 will be the area. Okay, the breakthrough strategy. Okay, then Six Sigma, how does it achieve improvement? So Six Sigma has its own breakthrough strategy, that is the step-by-step approach to improve things. And that is, so the original book on Six Sigma uses an 8-step approach, which is given by Michael Harvey and Schroeder. They use an 8-step approach, but nowadays it has been simplified into a 5-step approach. So anyway, the 8-step approach is recognize, define, measure, analyze, improve, control, standardize, integrate. So this is the original approach. And then people have simplified into by eliminating this or hiding this recognize, standardize, and integrate as DMAIC, DMAN. So people say DMAN. So that's why Six Sigma has a lot of such acronyms. So when people use these terms, people who are not familiar with Six Sigma, they cannot follow. So sometimes they use a lot of terms like that. So benchmarking also they use with a lot of different terms. SIPOC approach. So many such terminologies are there. So, but once you learn, it is actually the same thing. Only they have packaged it different. So this is define, measure, analyze, improve, control. So basically this. So what means is, first of all, in order to achieve any improvement, you have to recognize some area where improvement is required. You have to recognize a problem. So for that, you can use benchmarking or etc. You compare with other companies. What is for example, what is the time taken to get payment? So that is one of the key important things to maintain the liquidity of a business. So once you recognize that, how can you speed up? So you define the problem. So what is the aim? So you have to define in quantitative terms. So to speed up the payments from say 6 weeks to 2 weeks. So initially you may say things like that, 6 to 2. So first you have to measure whether it is really correct. Are we really taking 6 weeks? Is it really taking 6 weeks to get a payment after delivery? So first thing is to measure your process. Then sometimes you may find that measurement shows that it is worse. Then it is all the more good. Sometimes measurement will show that it is not correct. Then we may have scrapped that project and go for a new project. So always starts and ends with measurement. Then we analyze what are the possible causes of the problem. So we use a cause and effect diagram and then try to identify all potential causes. So now we don't know whether they are really true or not. So that you verify through some, we analyze, we carry out experiments, etc., and identify which are the real causes of the problem. Then we improve. So that causes we attack. So we eliminate those causes or introduce steps in the process to bypass those causes. So we try improvement and then we again measure. So this breakthrough strategy is not completely sequential. It is not in a line. That's why it is shown in a circular fashion. So we go back at any stage. So define, measure, we can again. So if measurement we find there's a problem in measurement, we can go back to recognize, we try for a new problem. Then analysis, we find a cause and improve, we find some improvement, we measure it. And then if there is no improvement, we have to again analyze the causes. So this is not a sequential step-by-step approach, but anywhere we can go back. So that is the important point about this breakthrough strategy. It is not that we have to start from one end and end, go to the other end. Improve. So once you improve and you verify that there is improvement, you control. So we have to maintain that improvement. So many times people say we improve, like a person who says, I stopped smoking at least 30 times last year. So that means you have improved, but again you go back to the old problem. So that should not be there. How do we maintain that improvement? So that is the method of control. Okay, you have to ensure that the improvement is maintained. So then you standardize it. So the process is standardized. Your documentation all have to be revised so that everybody is aware what is the new standard. And then integrate throughout the organization. So maybe you improve one machine, but there are several machines in the organization. So improve all the machines. So that is integrate. And GE and all, they have to just produce throughout. There are other units also. So same product, it may be being made in United States, it may be being made in India also, it may be made in Africa, South Africa also. So everywhere they implemented the same improvements. So that is the process of integration. So large organizations, that is an important step. Okay, so this is very basically from the scientific method. Okay, so scientific method usually proceeds that way. So research methodology, if you recall. So again, it is not sequential. So that is why research methodology, we start with a hypothesis. So we formulate a hypothesis. So this is the possible reason, or we think that this, by doing this, we can achieve improvements in strength of the material. So, or by doing this, we can improve the tool life, or machinability can be improved, or machining can be made easy. So that is your hypothesis. Then you try it out, verify it, etc. What is scientific method? So define the question, gather information and resources, form the hypothesis, so recognize this here. Then this is the improved stage, then perform experiment. So you go back to measure, analyze data, interpret data and draw conclusions as serve as a starting point for new hypothesis, publish results, retest. Okay, so that is the scientific approach is closely connected. So from that only they have made it into a form suitable for industry people, that is this DMAG. Then Six Sigma also has a unique organization structure. So what happens is that many times when you try to improve something, so you may find that it actually the cause of the problem is in another department, and there you don't have control. So how do we ensure that the other department also cooperates? So that is why we have an interdepartmental project team. So at the top, we have the executive leader, the chief executive. Under him, whom we have a champion or sponsor. So this is for each project. So executive leader is for the entire organization. Champion or sponsor, who is interested in the improvement? Who will give the money for that improvement? So for example, if there is a problem in machining, okay, who is interested in machining, improving machining? The supplier department or purchase department may not be interested in improving the machine. So who will sponsor this improvement in machining? Maybe the production manager. He is the champion. So under this project, okay, improve the machining problem or reduce the or improve the tool life. That problem may be given to a project leader. So that project leader is the black belt. He is called the black belt. So black belt is the team leader. So under the black belt, we have several green belts. So they are the team members. So these team members are from different departments. Okay, they are not all from the same department. So, and to guide the black belt, we have a master black belt. So master black belt is an experienced black belt. So this is the organizational structure. So we have a new organizational structure when we implement Six Sigma, which is in addition to the existing organizational structure. So this is how we break down the barriers. So it all depends on how much importance is given by the executive leader. So the executive leader is supposed to give a lot of importance to Six Sigma. Then he will monitor the project improvement activities, and then the teams, he will review the team's progress, where he will interact with all the team members, and then he can give the necessary instructions in other departments also. So that is how this organizational structure changes the organizational culture of the changes the organizational culture. Okay, so what are black belts? Black belts are full-time members. So they are the project leaders. They work full-time on projects. So only one project? No, they'll have several projects. So generally it is for a period of 2 years. So every person is nominated as a black belt for 2 years, and he is he takes, in this 2-year period, he carries out 8 to 12 projects. That is the standard. Then, generally, we had a formula for how many black belts are there in the organization. So they had a formula 1 per 100. So we have 100 employees, we should have 1 black belt. So if we have 500 employees, we should have 5 black belts. So like that, there was a formula, how many black belts should be there. And under each black belt, there will be green belts. So the black belts, the choice of the people who are selected as black belts is very important. So we should choose the people who are on the fast track. They are the best people, okay, who are moving very fast, likely to get promoted, etc. So they said, okay, tell me who are your best people. And you should, the department heads usually gave the correct names, and then they were removed and made as black belts. So that was the way they were selected. So if you otherwise ask, say, I'm going to take away these people, then the department head will not give the best people. They will give only the people they don't want. So that means then there will be a problem. They are not on the fast track. They are not the good people. So their implementation also will be a problem. So if you use the best people for improvement, definitely there will be results. So what training does a black belt get? So generally they had full 4 weeks full-time training. So week 1 was 7 QC tools. So 7 QC tools first week. Okay, that is 7. We'll also start with that. And then week 2 was design of experiments. So these 2 are the most important tools. Week 1 tools are quite simple. So for engineers, perhaps week 1 tools are very easy. Whereas week 2 tools are not, design of experiments is not so well known in engineering, but now it is changing. So many courses, they are adding design of experiments to the courses. Week 3, QC tools, quality control tools. Other quality control tools are like reliability, etc. All these are taught. So it is actually quality control again, but in a different fashion. And week 4, soft skills. So soft skills is people management, how to implement improvement. So as Joram said, the biggest problem is the technical solution is usually easy, but making people follow the solution is the most difficult thing. So that was discovered by Joram. So when he was a young engineer, he used to go about telling people, okay, you just do this, that will be all solved. But then people will not follow that. So he was a young engineer. And when people, after he leaves, they'll tell themselves, who is this young engineer to tell me I have been doing like this for 50 years or 30 years? Who is he to tell me? I will do as I like. And they'll never follow what he told us. So that's how he realized that making people do things is not so easy. So we need something, how to make the people implement the solution. So that is the topic of this week 4. And black belt training, he has to do 2 projects. So then only he gets qualified as a black belt. So just after training, he's a green belt. Okay. And then once you do 2 projects and he succeeds, then he is identified as a black belt. Okay. So this is the training of a black belt. So the syllabus for black belt you can get from the ASQ website. Body of knowledge by ASQ is there. So you can see that website. I don't remember whether I have put it in the newsletter. Okay. So more detailed syllabus is available. So they have conduct examination, certified Six Sigma black belt exams. So they have to do 1 or 2 projects and give the results. Okay, so that is the training. So then master black belts. Master black belts are experienced black belts. So after they do 8 to 12 projects, they retire. Okay, that means they have no more black belt, but then they can act as a master black belt. Or they involve consultants. Usually the initial stages people won't be there. So then they bring in outside consultants as master black belts. So they are supposed to have knowledge of more advanced tools. So more expert in statistics and all are usually employed. There's one criteria like 20 projects they should have done to become a master black belt. Okay, these are a little, we can, every organization they can decide. It may not be exactly 20, maybe after 12 a black belt. Okay, if he does some more extra work, maybe he can be made a master black belt. Okay, so that is black belt, master black belt. Now we come to green belts. Green belts are only part-time members, so that's the difference. But they get full training, same training as black belt, 4-week full-time training. That is for 1 month, the people have to be relieved. So there is so much of training. That is a major input of Six Sigma. So the cost of Six Sigma is usually in this training so many people as a black belt. And unfortunately, they charge very high for this black belt training, which is high. Sometimes in India and all, many companies I have seen, they implement Six Sigma, but they don't give training to this many people. So GE used to give training like this, extensive training. So that means 1 in 100 should be a black belt. Plus you have 5 green belts. So at least 5 for each project you need. So under one black belt, there will be at least minimum 4 projects. So each project you need 5 green belts. So 20 black belts. That means 20-30% of all the people are trained in given extensive training. So more the numbers are much more. The people who are trained in Six Sigma is much more. And these are the people who act as change agents. Because of this training, they are able to change the organization. So they change the organization culture and push the organization forward towards quality improvement. Okay, so Six Sigma versus TQM. So TQM is also a methodology which focuses on quality improvement. But then what is the difference? So that is the difference we'll discuss. So Six Sigma is owned by the executive. So Six Sigma focuses on the chief executive. It is his job to monitor the project teams, select the projects, and ensure that the teams succeed. Whereas in TQM, usually we have self-directed work teams. So quality circles are there, focus teams, many different types of teams are there. But in quality circles and all, the team, they select the project themselves. So that is, when they are asked to select a project, they will choose whatever is of interest to them or convenient to them. Whereas when chief executive says, you have to do this project, this is the project which is important to the organization, then the most important problems are selected and given to the team for selection, for improvement. So that's why it is owned by the executive. Whereas TQM, there's no such, it's not very structured. Whereas in Six Sigma, it has to be done by, the problem has to be selected by the, or at least approved by the chief executive. Six Sigma is used as a business strategy execution system. So the problems are not only quality problems. So you choose all sorts of problems, like very commonly we find payment, cash flow is a problem in many organizations. So how to get the payment in time or fast. So it's viewed as a business strategy execution system. Whereas TQM is viewed as a quality initiative. So the focus is mostly on quality. So whereas Six Sigma, you can choose any problem. So customer satisfaction is sometimes viewed, or this problem of the customer is taken up as a problem, etc. Six Sigma is truly cross-functional. So all the team members are all from different departments. So it is ensured that we have a cross-functional composition. Whereas in TQM, it is largely within a single function. It is voluntary. The teams are voluntarily formed. If you want to form a team, nobody forces. So usually what happens, they choose members who are nearby them. So it ends up like members from the same department. So the teams are largely within a single function. There is no cross-functional team is not there. Focused training. So Six Sigma, we say we need some 20%, 30% people to be trained as black belts. So there is extensive training. Whereas in Six Sigma, it's not like that. So no mass training in statistics and quality. So there is nothing like that. TQM, what training? Okay, you decide what training you want. It is not very rigid. Whereas Six Sigma, there is a certain training. These are the tools that you have to learn. You have to learn 7QC tools. You have to learn design of experiments, etc. Then Six Sigma, always we have verifiable return on investment. Everything is measured in terms of money. So Six Sigma focus much on metrics, and there is verifiable return on investment is verified. Whether we are getting returns on investment is verified. Whereas in TQM, there is no such focus on return on investment. And it is business results oriented. So just like it's a business strategy execution, what is the aim of the organization? That is what we have to aim at. So business results, we should achieve this much profit, we should achieve this much return on investment. So it's business results oriented. Whereas quality, TQM, we focus on improve scrap, reduce rework, etc. So it is quality oriented. So now we have left with success stories. So 1998, Raytheon, Daniel P. Burnham implemented Six Sigma and saved $1 billion by 2001. Okay, it's all US case study. Polaroid was another company. Polaroid cameras, instant photographs we could get. But of course, with the digital technology coming up, digital cameras being common and mobile phones having cameras, I don't think now they are there in the picture. Then ACR Brown Boveri is another company which implemented Six Sigma in the initial stages. Okay, but so people always ask for Indian success stories, but people don't reveal things in India, especially where that is one problem with Indian story case studies. Okay, Six Sigma tells we don't know what we don't know. We can't do what we don't know. We won't know until we measure. We don't measure what we don't value. We don't value what we don't measure. So Sigma focus on measurement and monitoring that measurement till we achieve improvement. So Michael Harry, afterwards he retired and became a cowboy. So Six Sigma focuses very much on measurement. Okay, a Six Sigma organization. This is a definition of a Six Sigma organization. An organization that is actively working to build the themes and practices of Six Sigma into its daily management activities and is showing significant improvements in process performance and customer satisfaction. So this is in the book by Pandey et al. I think I mentioned the book in the list of books. So it is only necessary to show significant improvement, then we can call it a Six Sigma. But this is opposed by many people. What is the meaning of Six Sigma? Why do you want to say Six Sigma? Why don't you say 5 Sigma or 3 Sigma? So Anyway, there is no official definition of Six Sigma, so it is all up to you. So anybody can claim that I am a Six Sigma company using this definition. If you are showing significant improvements, you are a Six Sigma company. That's the definition by Pandey et al. So whether this is right, I don't know. Okay, so that is the important one. We need not achieve actual Six Sigma levels of performance on any process. So even GE, they have accomplished Six Sigma levels only in some processes. Not all processes is very much difficult. Even taking all your processes to 4 Sigma is a tremendous achievement. So that itself is very difficult. So, okay, so that itself will result in lot of improvement. But okay, so with that we complete the introduction to Six Sigma. So we have learned what is Six Sigma, what is the goal of Six Sigma, numerical goal, and what is the improvement strategy, the DMAC strategy, and recognize, etc. added in the complete list. Then what is a black belt, and what are green belts.